Hello. Today we will be discussing the method of calculating an electric charge of a charged object. I will begin by giving an overview of the specific problem we studied and the results we found, followed by the fundamental principles used to find these answers. Next, I will describe the calculations, code fragments, and model used to exemplify the problem, and finally, I will end by clarifying the assumptions made, analyzing the results, and answering a couple of questions. Now, the goal of this experiment was to determine the charge of a charged tape, known as a U-tape, using the electric force and gravitational force formulas. After applying these formulas, I found that the charge of the tape is equal to the square root of the electric force multiplied by the square of the distance between the two tapes divided by Coulomb's constant. Now, the reason that the two aforementioned formulas are vital to solving for the charge is the momentum principle, which states that in an isolated system, momentum is conserved. This principle is proven by Newton's third law, which states that for every action, there is an equal and opposite reaction. Therefore, when a collision occurs, the momentum prior to the collision is equal to the momentum after the collision. This is applicable to our experiment as it highlights the fact that there are two equal and opposite forces acting on our tape, gravitational and electric. By drawing a free body diagram, we see that these two forces are acting on the tape in the y direction, pulling down due to the force of gravity and pushing up due to another charged tape that is repelling our tape of interest. Since there are no other forces, we can focus on setting these two forces equal to each other, which gives us the formula mg is equal to kq squared over d squared. It is important to note that we can only use q2 in our electric force, or q squared in our electric force formula, if and only if we assume that the two tapes have an equal charge. We then plug in all the values into the formula and find that the value of Q is 2.14 times 10 to the negative 8 coulombs. We follow this calculation with a few others to learn more about the charge of the tape and how it compares to the overall tape. The first calculation is the number of deficient electrons, which illustrates just how positive the charge of the tape is, as these electrons have been displaced due to the positivity of the tape. Next, we calculate the total number of atoms and find the ratio of deficient electrons to the total atoms, giving us an idea of the strength of the charge. Illustrated here is a model of the situation we have been discussing, with the point charges representing the tapes and the arrows representing the two forces acting on tape B. As we can see, the electric and gravitational forces are equal to each other, thus proving the presence of Newton's third law. Now, as previously mentioned, there are a few simplifying assumptions we must make in order to reach these conclusions, which include assuming that the two tapes are of equal charge, that they are point charges, approximating the length of an atom to fit in a rectangular tape, and overlooking any measurement errors. To summarize, our results showed that the U-tapes had a positive charge, as indicated by the electron deficiency and the repelling of a negatively charged pen by the tapes. By using Newton's third law, we set the two forces acting on tape B equal to each other and found the charge of the tape, which we then used in different calculations to better understand the tape's charge. Again, the deficiency of the electrons does confirm that the tapes were positively charged. If, however, the proton and electron charges were switched, meaning that protons were negative and electrons were positive, the tapes would still repel each other, but they would instead be negatively charged and have an electron surplus. Additionally, it is vital that the tapes are only handled from the edges, as polarization causes the positive charges of the tapes to transfer to uncharged objects, which decreases the charge of the tapes. Thank you for watching.